this assessment asks us to use pKa values to estimate a KEQ for a non-acid-base reaction. And so we can approximate this by looking at these and considering the stability of the acetylide anion and compare that to the acidity or the stability of the chloride anion and determine whether the reaction should be favored in which direction and by how much. Well, qualitatively, we know that the chloride anion is significantly more stable than the acetylide anion, and so our quantitative prediction should match our qualitative prediction that it's going to proceed to the right. Well, if we take our acetylide and look at its conjugate acid, we can start to think about how much it's going to be favored. So the conjugate acid of acetylide is acetylene. It has a pKa of 25. If we look at the pKa of the conjugate acid of chloride, which is HCl, it has a pKa of -7. And so there's a difference in pKa units of 25 minus -7, or a difference of 32 pKa units. Since we expect the reaction to be favored to the right, we can estimate our KEQ as being around 10 to the 32. Note that this is different than how we use pKa's for acid-base equations, but if we were to spend some time doing a derivation, we'd see that it comes out to be the same. The same idea, we're going from a less stable anion to a more stable anion. These quantitatively tell us how different the stabilities are, and that's going to be reflected in this approximate KEQ.